all, there's something that you guys, there's these algebra manipulatives that you guys probably were never taught to use, which is kind of unfortunate, but every now and then I'll hold them up and show them to you and say stuff about them, but these are called algebra tiles, and they each represent something. So this big, well, let me start here. That is 1. That is -1. Okay? So when we say something is a perfect square, like the number 4, is a perfect square because it makes a perfect square. Isn't that cool? So the other perfect squares, well, also make perfect squares, you know. So 9 is a perfect square because it makes a perfect square. Yeah? Like it would really be good if I'm not good at this. Okay, but you know what I mean. So it makes a perfect square, I promise. Okay. My coordination is not good. But 8 is not a perfect square because it doesn't make a perfect square. Does that blow anybody's mind?
No.
No? Did your teachers teach you that?
Wait,
They didn't like show
I
it
remember,
visually.
I remember that in Algebra 1. We put
Good, I'm so glad.
circles
So it's so the perfect square 9 is a perfect square with a side of 3. So the square root.
3.
It's like mind blowing. Like nobody taught me that when I was in school. Okay, anyway, that's not the point. So if I turned this over and made it red, it would be -9. Everybody's okay? Okay. So this is X. So I had to have a different shape to represent X because you wouldn't want to confuse it with this. So back in ninth grade when we use these, it really is helpful when you're first, well, it really probably should be 8th grade now, when you're first learning whether or not you can combine like terms, because clearly I cannot add a green rectangle to a yellow square because they're not the same. So we would write functions and say, okay, that would be X plus 2, and that would be X minus 5, and if we were going to, and if we were going to add them all together, that would be 2x, and then when I put these together, those two cancel out, right? And you end up with just 2x minus 3 when you combine like terms, right? So that's how we teach it. Okay, so then this is x squared, because x times x would make x squared. They're like the perfect size. See how that works? Okay, so if I was going to create a trinomial, I would have x squared, like this one, x squared plus 2x plus 3. Yes? I'm going somewhere with this, I promise. Okay, so this is a trinomial, but it is not a perfect square trinomial. Because if I put these pieces like this, I have extra. So it's not a perfect square trinomial, right? I mean, I guess I could do that. But it's still not a perfect square trinomial. Everybody following?
Yes.
But this is a perfect square trinomial. Just like a perfect square is, 9, and it makes a perfect square. That makes a perfect square too. So this trinomial, x squared plus 2x plus 1, is what we call a perfect square trinomial. Y'all following? Okay, so if I were to factor this perfect square trinomial, it would factor as x plus 1, x plus 1. That's what makes it a perfect square, because it's x plus 1 squared. Yes? Everybody good? Okay, so now let's talk about completing the square. This will all make sense in just a minute why I just did all that. So on your page, it gives us an example of a trinomial. Now this one's not a perfect square trinomial, but it is a factorable trinomial, which you guys all know how to factor pretty well. So if you get to a quadratic, in all of this polynomial study that we did, when we got to a quadratic, you can always use the quadratic formula. It will always work, but factoring is easier. So if it'll factor, factor it. And that's what they're saying. We go ahead and factor, and you would solve it and get these two numbers. But if I get one like this, x squared plus 8x minus 10, I think about it, okay, factors of 10 that would combine and give you 8. 1 and 10 is 11. 2 and 5, 7 or 3. So there's not one. So I can't complete the square. I mean, I can't factor. You would have to use the quadratic formula. But there's another way. And it involves making this into a perfect square trinomial. So let's set it up. I'm going to set it up real quick. This is x squared, and I need 8x. Oh, I hope I have these. Oh, I'm going to do
Alright, there's
What's going on down there?
yeah, no, why? What's that? Okay, so there's. So if I was going to make a perfect square, how many things would they have 10 of these?
It would be 16.
Right, so that's the problem, is this is not a perfect square trinomial. It's an incomplete square. Huh. So I want to make it into a perfect square trinomial, which would be how many of these? 16, right? So what I'm going to do, and we're going to do it algebraically here in a minute, is I'm just going to take these out here. I'm going to get rid of these. I'm just going to move those out. And I'm going to put 16 in the place and make a perfect square trinomial. Now if I moved these out, where do you think I moved them? Cross the equal sign, to the other side. So I'm just going to move them to the other side, and I'm going to put 16 yellows over here. But because this is an equation, and I have to keep it balanced, if I put 16 yellows here, I got to put 16 on the other side also. Once I do that, just like that perfect square a minute ago, the factors are pretty easy to see by looking down the side. You remember I showed you on that square how there was 3 on each side. That's why. Bless you. That's why the square root of 9 is 3. So in this case, this perfect square trinomial that I just created, which is x squared plus 8x plus 16. What is it? Oh, not that side. Sorry, this side. What is the? Oh, you can even see that.
5.
What does this side say? X plus 4. Right? Which is the factors of x squared plus 8x plus 16. Right? Because I just made a perfect square trinomial. Okay, which means now I just did that so that I could factor this problem. I couldn't factor it before, but now I can because I made it factorable. Now, I'll deal with the right-hand side in just a minute because I moved out those 10. And so I can't just forget about them. I have to deal with them in a minute. But at least now this I can factor. And I don't have to deal with the quadratic formula or any of that mess anymore. Okay, so now you understand why it's called completing the square. Because we're taking something that was not a square and we're making it a square. So that's not like that. Don't do that. That doesn't work. But that's why it's called completing the square, okay? Okay, so that was that was fun. I'm going to play with toys for a little bit. And maybe in a minute, I think I'm going to show you something. Okay, now to this. Here's what you know. So here we go, we're going to do it algebraically, exactly what we just did. So the first thing we're going to do is I am going to move the 10 because that 10 isn't doing me any good right there. So I'm going to take that 10 and I'm going to move it to the other side, just like we did with those. We just got rid of the 10. And so I'm going to write x squared plus 8x. And now when I move the 10 across the equal sign, it does become positive. Now, it was real quick and easy. Jerry figured out for us how many of the little squares I needed. But the way that you figure it out, in case you were in case, I mean, obviously when you've got manipulatives, it's kind of easy to see. But when you don't have manipulatives and you just have numbers, this is how you figure out what number you need to plug right here in order to complete the square and make the shape work. You take your b value, that's this. Just like with the quadratic formula, it's the one that's with x. Half it. Now I'm going to write this step down and I'll explain why in just a minute. So I'm going to half b, which would give me 4. Now I'm going to square it. So if I square that, then I get 16. And isn't that how many yellows we added?
Yes.
All right. So now I am going to add that number to both sides so that my shape is now a perfect square. If I added the 16 here, you have to add it to the other side because that's what the laws of algebra say. All right, now this tells you exactly what we just noticed when we did it with the little algebra tiles. This left side is now a perfect square. It makes a perfect square shape. So we can factor it. It factors as x plus 4, x plus 4. Which equals 26. Which, yes, I heard somebody say it. So that's x plus 4 squared, right? So let's go ahead and write it as x plus 4 squared. I'm going to do that on the next line. I'll write it as x plus 4 squared equals 26. Is everybody good? Now, look what this says. The whole goal here is to solve. Get x by itself. Got to take the square root of both sides in order to get rid of the parentheses. So I'm going to take the square root of this side and this side. Now don't forget, when you take a square root, how many answers are there? 2, right? So what I've just done now is I've made this x plus 4 equals plus and minus square root 26. Everybody good? Flip to the top of the next page. Solve for x. All I got to do now is get x by itself, so just minus 4. So that means I have negative 4 plus or minus the square root 26. And you're done. We get the same answer if we plug it into the quadratic formula. Then it says use the calculator to approximate the solutions if necessary. Let's go ahead because it's on here and just plug it in your calculator real quick. It's 2 answers. Negative 4 plus square root 26. Sure. And negative 4 minus square root 26. And that's it. And we could do this same problem. So real quick, let's just do it with the quadratic formula so you can see the difference. So what was it? X squared? X squared plus 8x minus 10. All right, if we were doing this with a quadratic formula, our a value is 1, b is 8. Yay, chocolate pie! Thank you, Jacob.
He's in my section. Bye, Jacob. Good grade. Alright.
Okay, so quadratic formula is negative b, so negative 8 plus or minus the square root of b squared minus 4ac all over 2. Okay, so let's see, that's negative 8 plus or minus the square root of 64 plus 42. Negative 4 plus or minus the square root of 104. And I gotta break down 104. Twos. Sorry, somehow it doesn't come before until right here, where it becomes negative 4 plus or minus square root 26. Which is exactly the same thing we got when we completed the square. So it's just another way of doing the same thing. But an easier way, don't you think? I think so too. I think it's way easier. Plus, we're going to need it when we get to conic sections, which is what comes next, which we'll start on Monday. But we're going to complete the square today first. So let me give you another page. So that's like your completing square notes page. Gives you something to follow along. And now we're going to do a few, and then I'll show you the ones that I think you're probably better off just to use the quadratic formula. But we're going to, oh look, I probably got chocolate.
So
Yeah, they got to make chocolate pie, and my class made breakfast burritos.
Oh, yeah.
Oh, now I like a breakfast burrito too, though.
We're making ice cream.
Well, she said, like, second period to make breakfast burritos. She's like, well, y'all want to do that. But then her afternoon classes got to choose what they wanted to do.
We didn't.
And I'm like, I want to make chocolate pie for breakfast.
Sure, why not? But I do like breakfast burritos, so that would be good too.
why?
Okay, so I gave you the steps up here again. I'm going to walk you through another one, and then we're going to do one, which is the one that I personally, if this were me, SAT. Oh, which by the way, one of the reasons that I feel like I needed to go over this is when I went to do the SAT planning thing that I went to a couple weekends ago. The SAT has completing the square on it, and it asks you questions specifically using the wording completing the square, and I didn't want you guys to be like, what is completing the square? Because you can still solve with the quadratic formula, but you need to know what it is. So, we'll do one of the ones that I wouldn't solve that way personally, but we'll do it that way so that you can see it, you can always use completing the square also. Just like quadratic formula, it works every time. So you might get imaginaries with completing the square just like you do with quadratic formula, and that's okay. But there are problems that are easier to do with the quadratic formula. You'll see why in just a second. Okay, so let's do this one real quick. First thing we got to do is get rid of our 15 little squares because they do not make a perfect square underneath there. Move them to the other side. Now, if you'll leave a space right here, then you can save yourself like a step, because I can find my b value, half it squared, and add it to both sides, and just plug it in right there and just save a little paper. Now, I am, over here on this side, I am going to write out these steps, and I'll explain why in just a minute. So, my b value is -2. That's important, that it's negative. I have to half that, which would give me -1. And then I have to square that, which gives me +1, right? -1 squared gives you +1. And then you're going to add that to both sides. So +1, +1. So now I'm going to write my perfect square trinomial. Now I know, and you know, we can just factor this in our heads. But here's why I write this out to the side. Because when the problems get harder, if you did this step where you halved it, that is the factoring step. That is the factor. So it's going to factor as x minus 1, right? Which means I can write it as x minus 1 squared and now I take the square root of both sides, which gives me x minus 1 equals positive and -4. So you're going to end up with two answers. X equals 4. Right? No. X equals 5. I can't add. And x equals -3. Is everybody okay? Because you add 1 to 4 and to negative. Everybody okay? Now, if I go back and look at it, I'm like, well, I could have factored that. Yes, you could have. But completing the square always works, whether it's factorable or non-factorable, imaginary, irrational, doesn't matter. Completing the square always works, just like a quadratic formula. Okay, looking at number 2. They have already moved your C value. That is nice. So go ahead and factor number 2. Or don't factor it. It does factor, by the way. But don't factor it. Go ahead and complete the square. Everybody good? Yes, you could have factored the opposite answers. Okay. So now, starting on problem number 3, this is where things get a little bit not as easy with completing the square. Because I have a lead coefficient, and that kind of complicates things a little bit. This is an example of a problem where I personally would probably go ahead and solve this one with quadratic formula instead, but we are going to go ahead and complete the squares, because when we do conic sections, we'll have problems kind of like this, and we'll have to complete the squares. Okay, so we are still going to kick out the constant. You're going to move it over. So I'm going to move 7 to the